power, receive signal. What am I shooting for? Negative 44, negative 42. You know, if you're hiring a tower crew, they call you, oh yes, I'm done. What do you got? Oh, negative 52. Are you sure about that? Yeah, that's the best we can get it. Well, I'm sorry, I'm not signing off. The PCN and Triangle said negative 42. You're 10 dBs off. Now that we're talking about RSSI, the ODU itself, when it goes on the back of the antenna, there's a polarization to note. The V is pointing up, it's vertical. The H is pointing, well, in this case, pointing sideways horizontal, that's a horizontal link. On licensed links, polarization has to be the same on both sides of the link. If it's a vertical link, both sides have to be vertical, horizontal, both sides horizontal. On the StrataLink 24 GHz is the only product that has to be cross-polarized. 1V, 1H. Wow. Yes, I know the look, yes. Licensed links, same polarization both sides. Now where I'm going with this, remember I told you I want a negative 42? If you have a link that has a 20 dB difference and you don't explain why, 9 out of 10 is because you're cross-polarized. If you cross-polarize, you're gonna get a negative 60 on one side, the other one's gonna be negative 40. So 9 out of 10 is gonna be your polarization. Now, when you go into combiners, I'm gonna give you more tips because that's when you get a little bit confused. The combiner dictates the polarity, not the ODU. So we're gonna actually see a couple of them here, okay? Now, we said before sparing purposes, right? SM24, it's a single core radio. There's nothing to replace, it's only one piece of metal. You can get another one off the shelf and put it up and it's fine. For the licensed gear, 2 parts, ODU, OMU. But what happens? A licensed link, microwave link has 2 parts to it. A low side transmitter and a high side transmitter. Your V side is always your high side transmitter. Your A side is your low side transmitter. And then your PCN is going to tell you where it's supposed to physically be located. It could happen. Well, here, take it to the side. There you go. Go ahead, go, run. Maybe you give the guy the wrong side. You're going to be transmitting on the opposite side. What's the worst that could happen? The link is going to work, but you may be impacting somebody else in the tower because the PCN already checked the actual available space in the tower. So to avoid any inconvenience to your fellow microwaves there, please check now which is your side. On the ODU itself, it's a sticker. It's going to say A or B. A, low side, B, high side. Now, when you read this ODU, it's going to tell you 23 gigs, that's the frequency band. TR, 1200 or 490, that's the spacing between frequencies. Low, and B or A. Now this is, for example, an HP1, which is one manufacturer, 23 gigs, 1200 TR spacing, and 6A. This is an A side radio. For spreading purposes, every microwave link, one side's A, one side's B. If I have 2 A's, it will not work. 2 B's, it will not work. So where I'm going with this? You must buy spare ODUs. It's rare for an ODU to fail out of thin air, but if it gets struck by lightning, which is the most common case, you have to have a spare. And what happens? Sparing. Typically, lightning hits on Friday afternoon, Friday at 8 o'clock, you know, things like that. And when you call RAID that time, our cutoff time is out. We cannot send you anything until Monday. So if you have spares, you're going to minimize your downtime, okay? Just make sure you have the correct side. Now, when you're building your network or your microwave back or going back, you can probably use same frequency bands. You can have a couple for multiple sites, multiple jumps, right? So you can work without the RAID or something like that for the actual spreading purposes. But yes, just make sure they have the right spare for the right side and have A or B.
So on an XPIC system, like, I mean, do I need one for vertical and one for horizontal, or that's universal?
No,
as long as it's low side or high side, it'll work
correct.
for either.
On that scenario, for example, if you have a 2+0 system, again with XPIC, both sides are going to be A both sides are gonna be B.
Okay.
So that doesn't change. In vertical horizontal, one ODU has both polarities.
Right.
It's pretty much inside. There's a waveguide in there.
Yeah.
And if it's vertical horizontal, that will determines how the antenna will actually forward. The
Okay.
antenna itself, if you see one of the back of the antennas for any of our, even that one, the waveguide is cylindrical. There's no up and down, left or right. I mean, it's just the waveguide going straight. What sets it is internal, but it's here.
Okay.
You might have two channels though. Yeah, I mean, two different radios, because let's say it's 11 gig, you got 3 different subbands to cover the entire 11 gigahertz
Oh,
frequency.
okay.
So if you had a band 7 radio and a band 6 combo,
Mm-hmm.
You must have spares for each band,
Okay.
because the frequencies won't be in the same place.
Spares for each band, right?
So that's that's the thing you have to worry about microwave. When spreading purposes, IDUs I'm not worried about because you can have black boxes out of the box. I mean, just on your
Right.
shelf. This doesn't carry the frequency, doesn't carry the IP at all. This is a blank box that will actually just assign whatever you tell it. Remember, this detects the frequency. This is just a device that tells, okay, I'm gonna forward traffic and this is my IP. Now, if this one, by any reason, gets chosen, see this little IF cable? This is the same as having an LMR 400 cable 1,000 feet apart. Right? So, if this one, for any reason, gets struck by lightning or something, we do not encourage and allow field ODU replacements. So this has to come back entirely to us. And then we'll send you another one back with the ODU either repaired or replaced. So just think about that for installation purposes, ease of troubleshooting as well. If it's feasible for you to have IDUs, just have a tech out to replace just a box, you're done. Instead of having to climb or something like that.
So is the IDU, is there any configuration in an IDU?
Yes.
Oh, there is?
Yeah,
So,
IP,
okay.
SNMP.
Oh, okay, that is in the
That
IDU.
is in the actual.
Oh, okay.
But what I mean is blank is that you can set it however you want it, and the frequency is going to be set based on this guy.
Right.
So, you can have 2 or 3 spares of those, but in case, but ODUs, you must have a specific side, A or B. So that's when you have to start planning ahead, right? What if this is my main link. If it goes down because, the lightning strike, something happens, a transmitter, IF cable, something shorts out, you want to have that fast. So that's the other thing you want to just, beforehand, be sure you have it.
We have 3 sets of everyone because we have techs in 3 different areas across the state. So
Wow.
They all have their own sparing. So we don't have to travel a spare 500, 600 miles. So we have sparing in each one of our locations.
That's really good. I mean, see, by experience, if something happens, you still have an ODU in place. And I think you can do split systems, so that's
We use all
also
split systems.
split systems, right?
Again, the same reason. I have one tech in a building, so he can go look at the IDU, do whatever he has to do. Doesn't have to climb a tower and wait for somebody to come 300 miles to climb a tower, so he can have somebody there, right? So we do all split now.
Yes.
So all the IDUs, say in links, they don't care what band.
Nope.
It's just interfaces.
Just interfaces. So this,
Right.
remember, the IDU is going to say, whatever you connect to me, I'm going to be happy. I don't care if it's 6, first of all, frequency 6, 11, 23. I'm going to still just read it and just forward traffic.
LMR is looking good.
Everything's fine. Yeah.
So we converted a 300 meg ring to a gig ring this last year, and all we had to do is switch out the IDUs.
They went from pluses to links, right?
We went from
Or
plus to
lines.
links.
Links, yeah.
Yeah, we went from plus to links. We had to put the combiners on there, but other than that,
PLA, remember?
Yep.
Yeah, I work with Brian to get that up. Yep.
Yep.
So again, an easy switch, just an upgrade on the box and 700 into it.
Is there programming involved or anything when you switch those out, or?
Just have the same IP, and then the actual modulation is going to go up, so it just forward traffic. Really, that's all. Questions on sparing? So we got into the topic because we're going to RSSI, polarization, but I wanted to touch bases on the actual A and B side. Okay? A is going to be your low side transmitter, B your high side transmitter. Now, Luis asked me a good question. How do I know, once it's up in the tower, what is connected to my ODU? What is it an A or a B? We have to go out there with binoculars and take a look at the tower, of course. Now I'm kidding. The model command, remember I told you that, the model command, that's going to tell you what ODU is connected to my IDU. Going to give you the model, A or B, and the frequency range limits. I'm going to show it to you before we leave it.
Huh? This is my desk in Oregon.
Okay, alignment process. So we're going to continue here with the alignment process. Course alignment. First, we're going to rough align the actual ditch itself. We're going to loosen the nuts on the mount, the bracket itself. First, we're going to go azimuths, left to right. What's going to happen? When you go all the way left, your bolt meter is going to show 0 bolts. When you come back, as you move it ever so slightly, you're going to have a voltage spike. And you're going to think, oh, I'm done, I did it, I'm right there. No, that is the side of the frequency. So you're going to be moving it around, left, going right, right, right. Oh, 2.5, leave it up. No, keep going. You're going to drop. Suddenly, what happened to my voltage? It's going to drop. It's going to drop, you're going to keep moving it, it's going to come up again. That is your center frequency. That is what you want to hit. If you go further right, it's going to drop again and come up again. Think of it as a bullseye. Okay, when you're shooting darts, guns, anything, you want to hit the center, right? So that's the same principle here. You're going to do it a couple times. Go all the way out, 0, come back, see the side lobe, center frequency, side lobe, and then go all the way out. Once you did the left and right azimuth, you're going to go elevation, okay? Up and down. You got to lock one side. Then when you finish one side, tell your partner, okay, I did my side, now it's your turn. You're going to do your side. Now, what I said before, if it's an alignment problem, RSSI is going to be symmetrical. So when you see your partner move the antenna, you're going to see the voltage go up and down, up and down. He's going to see the exact same thing on the far side. Okay? Now, once you've done the rough alignment, you tighten down the bolts. On the mount itself, they're fine-tuned adjustment bolts. Now, those bolts are designed only to be turned half a turn, quarter of a turn, ever so slowly. Just okay, azimuth first. Go left, left. You're turning it. And you're going to see the voltmeter go 0.5, maybe 1 volt more, okay? This is the fine tuning. But in this, right now, if you bump it, you're going to see what I'm talking about. The RSI is going to go up and down. The voltage, 2, 3 volts, 2, 3 volts. So you got to keep it really, really still. Once you do your fine adjustment, call your partner, the far side team. I'm done, it's your turn now. When he moves it as well, you're going to look at the actual voltmeter. It has to be the same. When you're done, okay, what do you have? I have 3.2 volts. I have 3.2 volts. Great. We're on the same page. One thing is, when you're done, okay, lock it up. Let's go. Before you leave the site, do not disconnect the voltmeter. It happens a lot of times that you disconnect the voltmeter and you ratchet down. Really tough. By that, I don't know. Remember, it's order of 1 degree to VB. So tell your partner, okay, ratchet down. If he's ratcheting it down, you seeing it's actually moving, hold on. Untie it, go back in a little bit, and slowly do it, okay? It happens too many times. We want to go out of the tower, we're done, it's hot, it's humid, whatever it is, we want to get out of it. When you ratchet the final thing down, it is where the problems happen, the fine tuning. So just take your time with that and be patient. Check RSSI. If there's a discrepancy between the measured RSSI and the RSSI predicted, let's say that the guy did the best job he could, right? He got a negative 55, but the PCN says negative 42. I'm not saying that we may not make a mistake. Ray may put another 0 there or no. So you can always come back and recheck the PCN or at least the path profile. Okay. Verify the ODUs are mounted to the same polarization. Again, both sides for the licensed radios, they're both vertical or both horizontal. If they're cross-polarized, what are we gonna see typically? 20 dB difference, okay? So that's a classic example. Confirm the Fresnel zone is not unobstructed. If there's something in the middle and you see a little hill, that could be a problem. Now, when do you want to check your Fresnel zone? On the middle point. If it's a 10-mile link, at the 5-mile point, if there's anything there that's the most critical part, that has to be clear. Review the accuracy of path calculations. We use path laws 5 and 4, but there's tons of tools. Radio Mobile Deluxe, competitors have tools that are close to it. Even other vendors have online tools. You can download spreadsheets that will do it for you as well. Just GPS coordinates and you're done. So there's more tools than just us. I mean, you want to double check it, go ahead. But for those who have an iOS device, Apple fanboys out there, we have an actual application, and it's called PathCheck, and it's free. So you can download it, and you can put point A, point B, and it will actually give you a rough estimate if it's going to work or not. You can pick your frequency, antenna sizes, transmit power, how much bandwidth you need, and reliability. Again, it's just a rough estimate. You have two setups. The quick calc, and if you want more details, you put the coordinates in and you request a path profile, and then Ray will come back to you with a real profile. Right, Ray?
Android app before?
I don't really know if there's Android that works, but I don't know why you want Android really yet. But that's okay. Yeah, it's coming. I won't tell you any date because I really don't know when, but we talk about it. Okay. If it does not get to the RSSI, go back to a rough alignment and repeat. Again, this is going to be a process of patience and repeating a couple times.
And just as a clarification, now RSSI is the number that we're translating on the voltmeter
Yes.
conversion chart.
Correct.
Right.
So you're going to see your table, and you're going to see 0 volts to...
Yeah.
It is different for the SM24, the unlicensed, because it's a lot lower, less power. This is only from 0 to -20. The licensed here goes all the way to 26 dBm.
So is there any reason that you'd expect that if we did this alignment, we kept watching while we tightened the bolts down, we moved out from the dish, we did the dance, killed the goat, everything, the number stayed, didn't move, and then we climbed down and the MSE would be crap?
If the MSE is bad, that's interference or a bad IF cable.
Okay.
The MSE.
If the MSE, so really so do we get an expected MSE on our link? We get a number on there, don't we?
No, remember, MSE digital modulation. So if you
Right.
build the link for QAM 1024, your MSE minimal spectrum must be above 35.2. That's the MSE you're looking for.
So is that in the documentation somewhere?
That's documentation, and you
Okay.
can always do the ACM command with CLI, and you will get the thresholds. And
Okay.
it's on the data sheet as well.
Okay. So that basically, I need 35
0.2 above to
or,
get 1024.
or higher on my
Yes.
MSE.
Mhm.
Okay.
Yeah,
If, for example, if the link is designed for less, you will need less MSE, right? John?
the MSC, predicted MSC is not going to show up on the Path Plus report.
So again, because the
If
reason why-
everything is
depends on the
clean,
module.
it's a licensed link, you should be able to achieve
1024.
1024. Because the coordinator has all of our specs, so they know what it takes to get
1024.
1024. So if they did their job right, that license should enable you to get.
And if
The
I've
good
got a
MSE.
trashy old plus that only goes to 256 QAM,
Yeah,
then
MSE
it's still the same number.
Right.
It's, yeah, you
About
can, check, you can check the ACM. I think it's a little less for that. 256 is a little more forgiven.
Okay.
So as the higher modulation you go, the higher MSE you need. That's why higher modulation links are always more finicky to align.
Yeah.
Just wait for 4096.
To make it even worse.
Well,
Yeah.
that needs a better MSE, but
When's that coming out?
I'm gonna keep that secret.
You guys are coming out with 40-mile lasers that we're going to use to like bounce them off the dish.
So yeah, we're coming higher modulation, but I think that's worse for next year. Right now. John may know more than that. But yes, so MSE has to be correlated to the modulation. If the RSSI is plus or minus 3 dBs within your target, then you're done. Disable alignment mode. This is for the Apex Plus. Alignment mode can be off. The Orions don't believe have alignment. Enable ATPC if required. Proceed to link validation and commission. Rate for ATPC has to license on the PCN?
Yeah.
Yeah.
Yeah, I always do
Okay.
automatically. I tell them ATPC with ACM is going to be active. I don't know why you wouldn't, right? You want your ACM.
Yeah, they're going hand, but I just want to make sure that the point across was that ATP has to be licensed when you do the actual PCN.
Yeah. So on the PCN, it'll come back and it'll show you each of the modulation levels and it'll show you each of the transmit power levels. In some cases, depending on how crowded it is, they won't be able to get, you know, the actual highest transmit power at that certain modulation. They'll come back and say, you're going to be restricted at, you know, 32 QAM to whatever this transmit or whatever it is. But they'll let you know. And it'll be on the PCN.
So license link PCN, ATPC has to be in there. But Ray will take care of it. All right, guys, installation of the actual general, the antenna, the